So the question we are working with today is what mass of aluminum iodide is produced if 1.2 grams of aluminum and 2.4 grams of iodine react? So in this situation, we do not know which reactant is limiting and which is excess. So we would have to determine first which reactant is limiting, and that will therefore determine how much product will be produced. So in this case, we want to see how much of aluminum iodide can be produced by each reactant. So the first step is always to write and balance the equation of the reaction taking place. So I already have the reaction written down. It is aluminum plus iodine, which becomes aluminum iodide. To balance, we will have to put a 2 here and a 3 in front of the iodine, and then a 2 in front of the aluminum iodide. And this is the reaction in its perfect stoichiometric amount. Now we have to convert the number of moles from the mass that we are given for aluminum, use the needed mole ratio for aluminum and aluminum iodide, and then convert that to the mass of the product, which will tell us that if we used up all of our aluminum, how much aluminum iodide would be produced. So to do this, we are going to start with, again, the molar mass of the reactant. So it's going to be times 1 mole, and we are going to divide that by its molar mass, which is 26.98 grams of aluminum, and that is one bracket. So that's the molar mass of the reactant. Now we are going to do the mole ratio of aluminum to aluminum iodide, which is the product, and we are determining how much of it can be made, so we have to work with the mole ratio for that. So on top goes the number of moles of aluminum iodide, which is 2 moles. That's 2 moles of aluminum iodide divided by the amount of moles of aluminum, which is also 2 moles. And we are going to label these so that we do not get confused. This is aluminum iodide and this is aluminum. And for the molar ratio, we are looking at the coefficients in front of the reactant and product to know how much of the moles we are going to put for the molar ratio conversion. And then the last one is the molar mass of the product. So we want to convert the moles to the mass of aluminum iodide. So to do that, we're going to put the molar mass of aluminum iodide on the top, which is 407.68 grams of aluminum iodide. And we're going to divide that by 1 mole of aluminum iodide. So now we have 120 grams of aluminum, and then we're dividing that by its molar mass, so the grams get cancelled out. Now we're in moles of aluminum, and we are converting it to a mole of aluminum iodide. So let me just put the aluminum here, and then 1 mole and 1 mole, that gets divided out, and then the moles of aluminum iodide get cancelled out, and we end up with the grams, which is what we want. We want to know the mass of the product. And if we do all the calculations, we will end up with 18.1 gram of aluminum iodide. And this is if we use all of the aluminum given. So that's if we use up all of the 120 grams of aluminum. But we have to see which one is the limiting reactant, because that's the one that is completely used up. So in order to determine that, we have to do the iodine. We are going to repeat the same process for iodine that we did with aluminum to see how much iodine can produce aluminum iodide. So we begin with the same thing, the molar mass of the reactant. So 2.40 times, we want to go into moles of iodine, so I2 here. And then since it is I2, we're going to do iodine, the molar mass of iodine times 2, which is going to be 253.8 grams of iodine, I2. Because it is a diatomic particle, so when it's in an equation by itself, it's always I2. So the grams get cancelled out. We are no longer in grams of iodine 2. And then we're going to use the mole ratio again. And if we go back to the equation where we balanced it, the moles of iodine in the equation is 3. So it's a 3:2 ratio. So we're going to do times 2 moles of aluminum iodide, because we want to go into the mold of aluminum and we want to get rid of the mold of iodine. So 3 moles of iodine. And now the molds are cancelled out, so we are no longer in that unit. And then the last one again is the molar mass of the product. So this is the same conversion that we did with the aluminum iodide when we were doing that conversion. So this is 407.68 grams of aluminum iodide. And then we want to get rid of the mold of aluminum iodide, so we're going to put that at the bottom. And then this gets cancelled out, this gets cancelled out, and now we end up with grams of aluminum iodide. So the answer for this one will be 2.57 grams of aluminum iodide if we do all the calculations and follow the conversion brackets. So as we can see, the limiting reactant is always the reactant that produces the least amount of product, and when we compare 2.57 grams of aluminum iodide compared to how much the aluminum conversion gave us, which was 18.1, we can see that the limiting reactant is iodine and the excess is aluminum, and thus only 2.57 grams of aluminum iodide is created in this reaction. Now, in order to determine how much of the excess reactant is used and is left over, we need to follow the same steps that we did as before, except this time we're converting from the mass of the limiting reactant to the mass of the excess reactant to see how much of it exactly we did use up in the reaction. And then when we want to find out how much excess reactant is left over, we simply have to subtract the amount of excess reactant used up from the initial amount of the reactant that was given. So in this case, the excess reactant is aluminum and the limiting reactant is iodine. So we're going to start with iodine. So we used up fully 2.40 grams of iodine in this reaction. So we're going to do the same steps. We're going to go into moles of iodine. So 1 mole of iodine again is 253.8 grams iodine. And that is the molar mass. So this is the molar mass of the limiting reactant. And then we're going to go into mole ratio of limiting reactant to excess reactant. So on the top we'll go 2 moles of aluminum, because that is the reactant we want to end up in. And then on the bottom we'll go 3 moles of iodine. Again, we are using the same coefficients that we used to balance the equation. And we want to end up in mass, so we're going to use the molar mass of aluminum, of the excess reactant. So that will be 26.98 grams of aluminum. And over that will be 1 mole of aluminum, because we do not want our answer in moles. So 2.40 grams times 1 mole divided by grams again, so the grams get cancelled out, and then the moles of iodine get cancelled out, and then 2 moles of aluminum divided by 1 mole of aluminum. Again, the moles get cancelled out, and our answer, we will end up with grams of aluminum. And the answer is 0.17 grams of aluminum. So if we do all the calculations, that is the answer we will end up with, and this is the amount of aluminum that is actually used in the reaction. So only 0.17 grams of aluminum is used up in this reaction. So now we know how much reactant is used, excess reactant. But if we want to know how much of it is left over, all we have to do is begin with the initial amount of the excess reactant, which is 1.20 grams of aluminum. This is how much we began with, and we only used up 0.17 grams of aluminum. That's how much we used up, and that equals to 1.03 grams of aluminum, and this is how much of the excess reactant is left over.